So I'm going to start by reviewing what we actually did on Friday. So if you want to write this on number 5, that's okay. All we found, on the top we found the vertical asymptotes, and on the bottom we found the horizontal asymptotes. And so now what I'm going to do is I'm looking at problem number 5, and I'm going to review what we did on Friday. So if you look at the domain restriction one, the one that says domain restrictions on the top, under domain on the second sentence, what does it say? The domain is what? Okay, so before I reduce anything, I'm going to start with the domain, okay? So on top, the x minus 4 stays. On bottom, I factor. Y'all, take out your earbuds. Out. Take them out. Out. Because you're staring at the floor instead of listening to me. That's why. So, first of all, I know this is going to be my canceled term, correct? I know that the domain I have to find before I cancel. So the domain is going to be all real numbers. Well, I'm going to write it. Probably would like to. Except x cannot equal what? -4 and +4. So x minus 4 is my point of discontinuity. Okay, what did I just read on the domain? What does it say? Okay. So my reduced function is 1 over x plus 4. So to find the point of discontinuity, which is what I'm going to start with, I take the term that I canceled, which is x minus 4, and I set it equal to 0. So my x equals what? 4. Which is why the 4 goes in the restricted domain, because it can't be there because that's the hole. So how do I find the y value of my point of discontinuity? Right? So I'm going to take 1 over 4 plus 4. That's going to give me my y value, which is 1/8. So next, I want to find my vertical asymptote. My vertical asymptote is what makes the bottom 0. So the vertical asymptote is -4. So that's where the -4 goes in the restricted domain, and then the 4 goes in the restricted domain. All right? So next, let's look at the horizontal asymptote. Is there an x on top? Nope. So there's only an x on bottom, which makes this bottom heavy. If it's bottom heavy, what is the answer? Are you guys guessing? Are you looking? Bottom heavy is 0. Okay, so I did have in my last class some people asking. So on the bottom, I have x to the first power, right? And they wanted to know why it's bottom heavy. Is there an x on top? So that's like x to the 0 power, which makes it bottom heavy. Does that make sense? Okay, so bottom heavy gets y equals 0. So my x-intercept I get by setting the top equal to 0. Is there a variable there? If there's no variable, this is none. And my y-intercept I get by setting x equal to 0. So I get 0 and 1/4. The x-intercept is what's on top. There's none. Okay, so this is what we did on Friday. Okie dokie? I would believe that for sure. Okay. So now, the paper that you picked up in front, this is the last kind of asymptote I want to go over. Slant asymptote. So, when the numerator is greater than the denominator, there's no horizontal asymptote, right? Numerator, when it's top heavy, there's none, except for one specific case, and it's a slant asymptote. You guys should be so excited. We've never done this before. Isn't that kind of fun? So, which way, that's what you get for messing with your phone. I hope it cracked. No, it didn't. All right. So slant asymptote. If you had to guess, what do you think a slant asymptote would look like? Like a slant, right? It would look like a straight line. So I'm going to show you how to find the slant asymptote. And I want to start with number 2, because this one's easy. So slant asymptote, this is what I'm going to do. I have the 2x on bottom. I'm going to take 2x squared over 2x minus 4x over 2x. See how I just split it apart? Isn't that cute? So now we're going to reduce. It is cute. So 2 divided by 2 is 1. X squared divided by x is x. 4 divided by 2 is 2. And the x's cancel out. What is this an equation for now? It's an equation for a line, your slant asymptote. Isn't that fun? Look at that. Look how easy that was. It's going to be a slant asymptote if the top is bigger than the bottom by 1. So 2 is bigger than 1 by 1, so you have to divide it and get your slant asymptote. Okay. So let's do another example of that. Look at number 3. Okay. So the 2 is bigger than the 1 by 1. So I know there's a slant asymptote. There's no horizontal asymptote, but there is a slant. So I'm going to do this. So 2 divided by 2 is, so I get x, the x's cancel, and I get minus 2. Now just stop for a second. So the plus 3 over 2x, what do we call that? Starts with an R. Remainder, right? Right. Right. Okay. So this is, you guys are going to have to listen to me for a minute now. Just put your pencils down. You have to lift your actual head up, Isaac, and listen for a minute. Because this is kind of weird. So this is the remainder, right? So what this is telling me, if I drew x minus 2, if I put my line, it would look something like this. And so if this is my graph right here, this remainder part is how far away this is from the asymptote. This remainder tells me how far away this is from the asymptote. Okay? So, that's what it is. When we found the function, remember we found the function and you came up with the number? This is what this is telling you. It's telling you how far away from this the function actually is. But here's what I want to ask you. So, if I put 1 in here, what do I get for an answer? 3 over 2, so I get 1.5, right? What happens if I put 100 in here? 3 over 200. So, is that a big or a small amount? So what if I put 3 over 2,000? how about 3 over a million? So the limit, as this gets big, what happens to this number? What does it go to? It's going to 0, right? Does that make sense? The bigger the x, this goes to 0. So the end behavior here tells me this is going to 0, and we're going to ignore the remainder. So this is going to be my slant asymptote. We're just going to ignore it. Yep. Except we're really not ignoring it. We're taking the limit as x goes to infinity, it goes to 0. That's what we're doing. It's always going to go to 0 because it's different by 1. So it's always going to go to 0. Okay, so this one, so number 2 and number 3, it was a single term. And so we broke these apart and we divided. If it's this, which is x minus 2, we can use synthetic division. So am I going to put a -2 or a +2 here? +2. So I bring down the 1. 1 times 2 is 2. This is -2. 2 times -2 gives me -4. And what is the -1? And what did I just say we're doing with the remainders? So if I write the slant asymptote, it's x minus 2. Okay. So again, 3 is 1 bigger than 2. So this is slant asymptote. This is not a term. It's not a factor. So you have to use long division on this one. So I'm going to take the first term divided by the first term. Gives you 2x. So the 2x goes here. So this cancels, and when I subtract, I get minus 8x squared plus 11x minus 7. So I take the first term divided by the x squared. This is -8. Well, so what is the 27x minus 15? Remainder, so we don't care. Yes. So let's review. Slant asymptotes. If the top is bigger than the bottom by 1, if it's a single term, you can break it apart and divide. If it's a factor, you can do synthetic division. If it's anything else, you have to do long division. Okay? All right.